Welcome to Narayana online classes, Madhapur branch. Today we will discuss physics section of JEE Mains 2021, 24th February morning attempt. Let us begin. So the first question is, if two identical capacitors, one's connected in series, when C equivalent is C1 and one's connected in parallel, C equivalent is called C2, then we have to find the ratio of C1 and C2. So as we know, if we connect two equal capacitors in series, the equivalent will be C by 2. If we connect them in parallel, it becomes 2C. So the ratio which is asked, C1 upon C2, will be C by 2 divided by 2C, which is 1 by 4. And therefore, the fourth option will be correct in this. Let us move to the next question. So as you can see, there is a diagram in which there is a cube and 8 charges are kept on the vertices. All of them are plus q apart from 1. So 7 positive plus q charges and 1 is negative here minus q. We have to find the electric field at the center of the cube. Side length of the cube is considered as A. So what we can do is understand that field due to this positive charge and this positive charge will cancel at the center. Same way, field due to this positive charge and this positive charge diagonally opposite will cancel at the center. Field due to this positive charge and this positive charge will also cancel at the center due to equal magnitude and opposite directions. The field which will remain at the center will be due to this plus q charge and this minus q charge. So at the center of the cube, we can also say that the magnitude of field created by both should be identical. So we can write down the magnitude of field as, first of all, let's see magnitude. Magnitude I can write by doubling the field due to created by any one charge, that is 2 times kq upon distance square. As we know, the length of body diagonal is root 3a. So root 3a by 2 whole square. So this will become 8 kq divided by thrice a square. This is the magnitude of the field, and the direction is along the body diagonals towards the origin. So the vector along this E cap, unit vector along the electric field is going to be minus I cap minus j cap minus k cap divided by root 3. So we can multiply both of them to get the total electric field, and when we do that, first option is what we are going to get. Next question. If a transistor, if we increase the emitter current by 4 milliampere and corresponding increase in the collector current is 3.5 milliampere, we have to find the value of beta. So we can start by writing relation between the three currents. E equals IC plus IB. We are given the increase in emitter current and collector current. So we can create change equation by delta IE equals delta IC plus delta IB. We are given the increase in emitter current as 4. Corresponding change or increase in collector current is 3.5. So corresponding change in the base current can be calculated. The corresponding change in base current will be 0.5 milliampere. Okay. Now the definition of beta is change in collector current upon change in base current. So change in collector current is given as 3.5, this is 0.5. So just put the values and we are getting beta value as 7. So third option will be appropriate for this. Next. If W1 by W2 is 1 by 3 and it is given that amplitude is proportional to the width, we have to find I maximum upon I minimum. So as we know, I max will happen in constructive interference and I minimum will occur in destructive interference. So we can write down I max as A1 plus A2 whole square. It will be proportional to that, and minimum will be proportional to the difference in the magnitudes whole square, A1 minus A2 whole square. And in question it is given that amplitude is proportional to width. That means A1 upon A2 is 1 by 3 ratio of the width of the slit. So from here we can consider A1 as some A or A naught, so that A2 can be written as 3 times A naught. Now we can substitute in this that I max upon I minimum will be therefore equal to A naught plus 3 A naught, will get 16 A naught square, upon A1 minus A2 whole squared will be 4 A naught squared, which is 4:1. So 4:1 is present in the third option, hence third option is the correct key for this. Next question, if a small block of mass m is placed gently on capital M when it is passing through its mean position, find its new amplitude of SHM if initial amplitude was A. So when we are placing it on the capital M mass, suppose the velocity before placing the mass at the mean position was V0. As we know, V0 will be maximum initial velocity. Suppose it changes to a value V dash. V dash is new maximum velocity after keeping the mass. We can find out relation between V0 and V dash by conserving linear momentum. So if we do that, we'll get mV0 equals m plus m multiplied by V dash. So V dash would be mV0 upon m plus m. Now, question is asking us to find out the new amplitude if original amplitude was A. For that, we can write relation between maximum velocity and amplitude as A into original omega, let us call it omega naught. And similarly, final velocity can be linked with final amplitude or new amplitude and new angular frequency omega dash. So V dash I have found in terms of V0. Let us put the value here, m upon m plus m multiplied by V0. V0 I can write as A into original omega can be written as root of k by original mass. Originally only capital M was oscillating. Finally, one second, this is V dash m by m into V0, which is this. So V dash equals A dash into omega dash. Omega dash will be under root of k upon m plus m, because the total mass now oscillating is capital M plus m. We can just manipulate to find out the value of A dash from this. Okay, we are going to get the first option if we do this. Next question. From given velocity time graph, which of the following is the acceleration time graph? So we can see that in the beginning, velocity is decreasing with time. The slope of velocity time graph gives acceleration. So the slope is negative and then the slope suddenly becomes positive after that time. So initially acceleration will be negative and later on positive. We are using this definition to solve this. Acceleration is dv by dt. So initially acceleration should be negative, then positive. Only third option is giving us that possibility. So third option is the appropriate choice. Next. Two stars are rotating about their common center of mass. Find the period of revolution of mass small m about the center of mass. So we have to find time period of revolution for this. So center of mass of this system, if I locate, we can say that it will be at a distance of 2d by 3 from small letter m. Now for the purpose of finding time period, we will apply the concept that gravitational force will be equal to mass of that object into centripetal acceleration to provide circular motion. Gravitational force will be G m 2m divided by distance square. This will be equal to m omega square into 2d by 3. So we can simplify this to find out the value of omega. Let's do that. Mass term will cancel out. Omega square will be, this 2 also is getting cancelled. Omega square will come out to be 3 times G m upon d cube. So this implies omega will be under root of 3 gm by d cube. And finally, we can use time period and omega relationship to get the appropriate answer. Okay. Let us move to next question. Find the relation between modulus. All the three modulus, Young's modulus, bulk modulus and modulus of rigidity for a material are defined. We have to tick the correct option in this. So this is a fact-based question or a formula-based question which you have to know. In NCERT the relationship is given. So there is nothing to explain in this or derive in this. You need to know this. This is a fact-based question. Okay. Next. Circuit is given. Find the modulus of Vx minus Vy, where x and y are points mentioned in the diagram. So first of all, we will find out the current in the circuit. Let us see that the 6 volt battery is stronger than the 4 volt battery. So the direction of current will be this, right? And the magnitude of current we can find by total EMF, which will be 2 volt upon total resistance, which is 10 ohms. So 0.2 ampere will be the value of current. Now to find Vx minus Vy, we will start from point x and go towards y. So Vx plus 4 volts due to battery. In 8 ohm we'll find increase of potential, 8 into current, and we will reach point y, so this should be equal to Vy. So Vy minus Vx, which is the positive value which is asked here, the modulus, will be 4 plus 1.6. Therefore 5.6 volt is the appropriate answer, the first option in this. Okay. Next question. If work is alpha beta square into e to the power minus x square upon alpha into Boltzmann constant into temperature, we have to find the dimensional formula for beta. So to do this, first we will target the dimensional expression for alpha. As we can see, e to the power some expression is written. This x should be some kind of length dimension, so we can say that length square upon dimensions of alpha into Boltzmann constant into temperature, this should be a dimensionless quantity. Since anything which is present in the power of exponential thing, that should be dimensionless. Now Boltzmann constant into temperature from kinetic theory of gases, we can use directly that this is in the dimensions of energy. We see that kinetic energy is 3 by 2 kT. Using that, I can directly write dimensional formula for alpha will be length square divided by mass into velocity square. Velocity square dimensionally will be L square T minus 2. So this makes the overall dimensions of alpha as m minus 1 T squared. Now alpha into beta square therefore must have the dimensions of work, because this exponential quantity also will be a dimensionless quantity. So I can next say that alpha into beta square should have the dimensions of work. Alpha dimensions we are already now knowing, m power minus 1 T square into dimensions of beta square equals, work is also dimensionally same as energy, so I'll use that again, m into L square T minus 2. We can just simplify this to get dimensions of beta square as m square L square T power minus 4, and therefore the dimensions of beta are going to be equal to m L T minus 2. That will be the dimensional expression for beta. So as we see in the options, the first option is correctly indicating that, hence that is the correct key. Next question. Zener diode is connected in a circuit as shown. Find the current in the 2 kilo ohm resistance. In this we have to find. So as we can see, the Zener diode is of 5 volt. So whatever is happening here, we need not go into that. Directly I can say that there will be a potential difference of 5 volt across this 2 kilo ohm resistance. Therefore, the current flowing in this will be directly 5 volt divided by 2 kilo ohms, that is 2.5 milliampere. So the first option is directly correct. Next question. Given AB is isothermal and BC is isobaric and CA is isochoric process, find total work done in cyclic process. So in the cyclic process, we can first say that in C to A work done will be 0 because it is isochoric. For A to B, if I want to find out work done, work done in AB, let us call it W1, that will be equal to, for isothermal process, we can use nRT ln V final by V initial expression. So here nRT can be written as the product of pressure and volume at any one point. Let's say P2V1 I'll write. P2V1 into ln of final volume by initial volume, that is 2. The ratio of volumes is 2. One more thing we will have to understand here. In the process A to B, volume is getting doubled in isothermal conditions, so pressure should be getting half. So I can say that P2 should have double the value of P1. Using that, I can write this as 2 times P1V1 ln2. In question, they have given that P1V1 should be written as nRT. So I can write this as 2 times nRT ln2. Now coming to the process B to C. In the process BC, because it is isobaric, we can calculate work done in this. Suppose it is called W2. First thing, note that the volume is decreasing, so the work will be of negative sign, and the magnitude of work will be value of pressure into change in volume. Change in volume has a magnitude of V1. So minus P1V1. P1V1, if I write as nRT, this becomes minus nRT. So the total work we can write by just adding them algebraically. And if we do that, second option is the one which is obviously coming out to be true. Okay. Next. A side of a cube A is made from 6 identical sheets. If coefficient of linear expansion is alpha and temperature is now made T plus delta T from temperature T, then find the change in volume. So we can say that the initial volume V0 is A cube. The coefficient of volume expansion will be 3 times alpha. So delta V can be written as V0 gamma delta T, which will give us 3A cube alpha delta T. That's it. Nothing else to do here. First option is directly the correct one. Next question. 4 particles, each of mass 1 kg and equidistant from each other, move along a circle of radius 1 meter under the action of their mutual gravitational attraction. We have to find the speed of each particle. So let us start. This is, say, the circle. Radius of this circle is given 1 meter. We'll take it to be r and later put it 1. Let's say all the particles are located symmetrically at this position. Now because every particle is in symmetrical motion, we can do analysis for any one particle. Let's say we will do for the top particle. So on this particle there will be 3 forces applied by the 3 other particles. Their directions can be drawn like this. Let's say this is F1, this is F2. If between these two the force is F2, between these two also the force will be F2. So net force will be F1 plus 2 times, because this angle is 45 degrees, we can say that this will be 2 times F1, sorry, 1 second. This won't be F1, this would be F2. So this will be F1 plus 2 times F2 cos 45 degrees. What will be the expression of F1 if we write? F1 will be gm square by square of this distance. Radius is given as 1 meter. So this distance is 2 meters. So this force will be gm square by 4. Gm square by r square. F2 will be g m1 m2, both are same. So gm square divided by square of this distance. This distance as we know is root 2. So this will be 2. Now after putting the values of F1 and F2 in this, we can equate this to mv square by r, where again r is known to be 1 meters. Right? So just put these numbers in this and we will be getting the final answer for this question for the speed value of any one particle. Let's say this is the direction of velocity. Okay, next question. Choose the correct options. Column 1 is showing name of some thermodynamic processes, and right side in column 2 the conditions of that processes are mentioned. So adiabatic should definitely match with 4th, that is heat content is constant, right? So I'll just write the answer key here. P should match with 4. Isothermal, in isothermal as we know temperature remains constant, that is Q should match with 3. R is isochoric, isochoric means volume is constant, that is second option. And for S, isobaric, pressure will be constant, that is first option should match. So 4, 3, 2, 1, that is indicated in the first option itself. So first option would be correct for this. Next. Moment of inertia of ring of mass m and radius r about its diameter is mentioned as I1. So as we know, I1 will be about a diameter for a ring, we know mr square by 2 is the expression. I2 is defined as moment of inertia of disk of mass m and radius r through central axis perpendicular to the plane of the ring. Sorry, this should be disk. I2 is a disk object. So I2 will be also mr square by 2, that's a standard result. I3, moment of inertia of solid cylinder of mass m and radius r about its axis. I3 is also going to be the same, mr square by 2, that is also one standard result. I4 is moment of inertia of solid sphere through its diameter. That is also another standard result, which is 2 by 5 mr square for a solid sphere about diameter. Right? These are the values of I1, I2, I3 and I4. We can easily verify the options. When you do that, this is what is coming out to be true. Right? Next. Spectral lines of hydrogen atom is given below. So as you can see, 3 lines are shown, A, B and C. We have to tell which of the following is correct for these lines A, B and C. So as you can see, A is the transition from infinity to the first state, that is the ground state. So it should be the series limit of Lyman. Right? B is indicating 5 to 2 transition, so it is the third line of the Balmer series. And third is indicating the transition 5 to 2. So it is for the Paschen series, and that's the second line of Paschen series. Definition based question, the first option is the key. Next. De Broglie wavelength of proton varies inversely with linear momentum. To check this, just the definition that De Broglie wavelength of any particle will be defined as this, h by p, right? So the statement 1 is obviously true. As statement 2 is saying as lambda increases, energy and momentum increases. That's false. There is inverse relationship between them, as we know. Even energy is related with lambda as hc by lambda. So statement 2 is not correct. The first option is indicating that. Right? Next. A 220 volts AC supply is given to the primary circuit of transformer, and as output of 12 volt DC is taken out using rectifier. That means 12 volt can be treated as the RMS value of the output side. If secondary number of turns was 24, then the number of turns in the primary coil we have to comment. So we can directly use voltage across primary upon voltage across secondary. The ratio of these two RMS values can be directly linked with number of turns in primary to number of turns in secondary. Let's quickly see what data is given. Primary circuit has 220 volts of voltage, so 220 divided by voltage across secondary is obtained as 12 volts. This should be equal to number of turns in primary. What are the number of turns in primary is to be calculated, right? So NP divided by number of turns in secondary is given as 24. So number of turns in primary will come out to be 440. Next question. A vertical cross section of plane y equals x square by 4. Coefficient of friction is 0.5. We have to find maximum height at which particle can stay. In centimeters we have to report that. So directly we can use the concept of coefficient of restitution, that when the particle just starts to slip at that location, mu will be just equal to tan theta. Mu is given as 0.5, so half equals tan theta can be written as dy by dx. Dy by dx can be written from the equation of the graph as x upon 2. So the value of x comes out to be 1 meter at the limiting conditions, and the corresponding value of y can be obtained by substituting in this, that is 1 by 4 meter, or in centimeter he has asked, therefore 25 centimeters is the answer. Okay, next. Find out minimum force required to stop the block from falling by checking G as 10 meter per second square. So two forces will be important in vertical direction. One will be mg and one will be the friction from the surface. So our minimum force required, we can say that the normal which the wall will apply and the force which we are applying, let's call that force as F. First thing I can say that the normal will be equal to our applied force, and for minimum conditions I can say that limiting friction, that is mu times normal, should be just equal to mg. That is what will give the minimum value of applied force. So mu value is mentioned in the diagram as 0.2. 0.2 times the external force applied should be equal to mg. mg will be 5, right? So the force will come out to be of magnitude 25 newtons, right? This is 25 newtons. Next, two identical particles of same mass are shown just before collision and just after collision. So as you can see, two diagrams are given before and after collision. V1 by V2 we have to tell, where V1 is the velocity of m after collision, V2 is the velocity of the other particle after collision. What we can directly use is, if this is called x-axis, this is taken as y-axis, then initial momentum along y direction, if you see, that is 0. So even final momentum along y direction should remain 0 because of conservation of linear momentum. So if we apply that, we will get m v1 sine 30 degree equals m v2 sine 30 degree. That means v1 by v2 ratio is 1. Okay. Next question. If I is 20t plus 8 times t square, we have to find the charge flown during 0 to 15 seconds. So here we will use the definition of charge flown in terms of current as dq by dt is current, and current expression is given to us as 20t plus 8 times t square. So charge flown will be integration 20t plus 8t square dt, limits 0 to 15 seconds. This will give the total charge flown in that time. So we can obtain this as 20 into t square by 2 plus 8 t cube by 3, and the limits will be from 0 to 15. So we can put the values and easily compute whatever is the final result for this, right? Next, a 100 kg block can be lifted by placing a mass m on a piston of a hydraulic lift if diameter of piston placed at one end is increased by 4 times and that of second piston is decreased by 4 times. Now same mass m is placed at piston, then how many kg weight can be lifted up for the new setup? So as we know, in hydraulic lift setup, the change of pressure on both the sides or both the columns should be equivalent. So we can start by saying, suppose A1, A2 are the area values initially. So for initial conditions, say I is indicating initial conditions, I can write that 100 into G, that is mg of this block, divided by the area at its location initially, can be linked with the other side, mg divided by A2, right? So from here I can write A1 by A2 as, this goes away, A1 by A2 will come out to be 100 upon m, right? And for the final setup, when we have changed the areas, I can write, we have to find how much mass we can lift. On the other side, the same small letter m mass is being kept. So say the new mass is capital M, so capital Mg divided by, is saying that diameter of piston placed at the one end is increased by 4 times. If diameter is increased by 4 times, then the area will increase by 16 times. So this will be 16 times A1. This should be equal to same mg divided by. Second piston diameter is decreased by 4 times. That means the area A2 will become A2 divided by 16. So we can do the new calculations. Suppose again I will compute A1 by A2 ratio. A1 by A2 can be written as, this will become m upon 16 square, that is 256. 1 minute. upon 256, right? So another ratio also we are having at our end, 256 m, and the other side same ratio can be written as 100 upon m as well. So this m will cancel out, and the value of capital M which we obtain will be 25600 kgs. Sorry. The new value will be 25600 kilograms. So 25600 should be the result. Next. Two planets are revolving about a planet. It should be a star, I guess, with T1 by T2 as 1 by 8. Find the ratio of angular speed omega 1 by omega 2. This is directly based on this expression or formula that time period is 2 pi by omega. So if T1 by T2 is 1 by 8 and T is inversely proportional to omega, omega 1 by omega 2 must be equal to 8. That's it. Next. An electromagnetic wave is propagating in a medium where mu r and epsilon r both are 2. If speed of light in medium is x into 10 power 7 meter per second, we have to find out x. So we can first find out the refractive index of this. Okay, since mu is being used for the permeability, let us call the refractive index by n. So n can be written as under root of mu r, epsilon r, both are 2, so this is square root of 4, which is 2. So speed of light in this medium will be c upon refractive index. That will give us 1.5 into 10 to the power 8. So 15 into 10 to the power 7 meters per second. He is asking x into 10 power 7, so the value of x should be 15. Right. Next. Vm is 20 sine pi t plus pi by 4 and Vc is given to be 80 sine 10 power 4 pi t plus pi by 6. For amplitude modulation wave, find out percentage modulation index. So as we know, in percentage term we can convert later. Modulation index is defined as magnitude of this, that is Vm by Vc we can call it, where both are the amplitudes of their respective functions. So this comes out to be 20 by 80, that is 1/4. So in percentage terms it will be 25%, right? Next. In AC series RLC resonance circuit, resistance R is 6.28 ohms, frequency is 10 megahertz and self-inductance is 2 into 10 power minus 4 Henry. Find quality factor of the circuit. So quality factor formula we can directly use. XL upon the resistance. XL can be written as omega L upon resistance. Frequency is given 10 megahertz. Omega can be written as 2 pi into frequency. Frequency is 10 megahertz. So 10 into 10 to the power 6 hertz. Multiplied by self-inductance. Self-inductance is given 2 into 10 power minus 4. Divided by the resistance. Resistance is given 6.28. 6.28 will obviously write it as 2 pi. It will help us do the calculations. So we can compute this. This will come out to be 2 into 10 to the power 3. That is 2000. The quality factor of this will come out to be 2000. Okay. So that was the last question. Thank you.